Okay, so in our last video, we had successfully parsed all of the tokens that are in our test file. Now that we have a nice array of tokens, it is time to go and iterate through all of our tokens and construct an abstract syntax tree in the process. So in order to do that, the first thing that we'll do is create a new file, and we can call it ast.rs, and we'll have a function here. Let's call it public ast builder, and we will have it so that our ast builder will take our tokens, and we will just require that that be something that implements the iterator trait where the item that we use there is a token type from our parser, and that can return an AST abstract syntax tree. I'm surprised that I'm not being yelled at, but that's all right. Oh, it's because I didn't. No, maybe it's because we're not using it yet. So then over here, let's get our AST, and we will let our AST be the result of passing parsed into our AST. So here we've collected our parsed, so we'll have to get rid of that, so that way we still have the iterator struct implemented, and because of that we don't have a collection, we have an iterable. Okay, and here, instead of being interested in our parsed tokens, we'll be interested in observing our AST. And here we need to go into our AST module, and I put the wrong thing in our AST builder. This is parsed. Okay, now we see some things over here. Right, so we aren't using some of the things that we need. We need our parser, and we need to define our AST. So let's do struct AST, and basically our AST is just going to be a list of functions. So let's do pub module will basically just be a vector of functions, and we'll need to define, let's call it a module. I think it's upset that we're using a keyword. And then we'll also need our funcs. So pub func struct func, and our func is basically going to be comprised of the parts of a function. So a func can have an export, params, a result, and then a function body. So let's go ahead and define those. So that will be a export, which will just be a string. Our params will be a vec of these, and so those could be any of our wasm primitive types. So let's actually go ahead and define an enum with all of the wasm primitive types. So that is, that'll just be I32, I64, F32, f64, and we'll do a null too, in case that we end up needing that. And let's do, yeah, so this will be a vector of our wasm primitives. And next will be the body. And that can just be a vector of strings. And finally, the result. And that is just going to be one of our wasm primitives. Okay, and so why don't we let AST be an AST where our module is just a new vector. And then return our AST. And then, let's see, we don't have a debug implemented for our AST, which means that we're probably going to end up with a chain of that implementing debugs, or deriving debugs rather. And there's something going on with my keyboard where it's making a noise. Give me one moment to adjust that. And yeah, as predicted, we probably have to do that for func and also for our primitives. All right, no red. Let's take a look at what happens. And bam, we have our AST, which is comprised of a module, and our module doesn't have any functions in it. So, yeah, let's go and iterate through all of our tokens here and construct our AST as we're doing so. We're definitely going to have to make this a mutable variable. And let's see, so while let sum mute token be our next token. So we do one iteration of our iterable tokens. And we need to declare this guy is mutable as well. Okay. Let's match on what kind of token we are working with. Okay. And why don't we kind of just go through and look at what the various things are that we'll encounter. So we have a left paren. So in that case, we would be looking at tokens, token types, and belpar. In which case, we don't really need to add anything to our list of functions. We haven't encountered a function yet. We kind of almost have our initial module declaration as like boilerplate that doesn't really impact our abstract syntax tree too much. So we can just go ahead and skip that. Similarly, the module keyword and I think a closing paren as well should be handled similarly. Let's go ahead and, oh, do we not have tokens? That should get rid of our red squiggle here. Beautiful. Let's have our wildcard. Let's do the same thing for rpar and module. Okay, and why don't we let's print here too, just so that we can make sure that we are working with a token that we think that we're working with each time. So say the token and the token. All right, and so if we do a little run over here, cool. We are indeed running through all of the tokens, and now we're at our first func declaration. So let's go ahead and handle that one. So in the event that we are looking at a func, let's have some state that we can use to like a Boolean value that we can use to because I think we're going to end up doing a while loop that we'll need to learn to break out of. So let's do let mute func def start off as true, and let's also have a current func kind of a node that we are going to construct that will then at the end of our function declaration throw into our abstract syntax tree, because again, so far we haven't modified our abstract syntax tree at all. So this will be let mute cur func, and this can just be an empty function. So what were our export params body result? And we need to, I think export is a string, params is a vector. Let's do body is a vector, and result is a wasm primitive. Cool. And so if we have encountered a func, the very first thing that we need to do is move on to the next token. So we'll go ahead and do a tokens.next. And which is almost like a skip kind of. But again, at the beginning of each while loop, we also do an iteration. So we're just ready to do a next iteration, so that way when we do our tokens next, or actually we're still not doing we don't have we're not going back up there yet. Let's instead look at our next tokens down here. So let's do, and we'll call this a potential token. So basically this is almost, you can kind of think of this almost as a what's it called in like JavaScript, the question mark at like optional chaining, where we're basically making sure, because again, that once we're done iterating, there isn't actually a next token that is the result of calling tokens.next. So this is kind of like safeguarding our tokens. And so here we will let our token be our potential token if that exists. Okay. Next, we will go and scan until we're at the end of our function definition. So again, right now we're right around here. And so our current token in this case, we did one skip here to get us through. And so now we should be looking at an export. So here we'll match, well, we'll have a while func def, and we will match again on the kind of our token. The first thing that we will likely encounter is our export. So this would be tokens, token types, export. And so if we do that, we again need to move forward and look at that and at the next token after our export, and that is what we're going to modify our current function to be. So we already have a potential token. Let's do a next token. Equals tokens next. And I'm going to print a cur func here too, so that we can see what our function looks like as we're constructing it. One there. Cool. This token. We will have our export be reference to the value, which again, so this is a reference to add 2. Over here, I'm gonna try and get that to stop making noise with a wildcard. Beautiful. And then we can change our current function's export to be a string from our export. Yes, and then let's take a look down here. Okay, and it looks like something is wrong. It actually might not be wrong, and we might have just gone through too far. Let's see. Oh, we never move on. Let's try moving on and see if we can get a clearer idea of why things are working the way that they are. I mean, we're definitely never breaking out of our while loop, so there's that. Yeah, so let's try advancing. So again, we're going to have to look at the next token. So if let's potential next, and here our token will be our potential token. Okay, let's try and break after that too. Let's see what happens. So our break would happen right here. Okay, so we go all the way through. We end up with a current function, our current function right there. Let's do, before we break, let's do our log right there. Okay, and we actually see that our export is getting correctly added to our current function. Next, let's see. We moved forward. We need to handle the case where we have a right paren. So if we have a right paren inside of our function definitions, let's do okay. Let's think about this. Well, then we just need to skip forward. So we will do bad habit of forgetting my fat arrows. And this will be token. Right. And continue. And let's do the same for a left paren while we're at it. Okay. And now we have our param declaration. So in this case, before we do that, let's take a look at it. Make sure we're still good. Cool. So yeah. All right. So again, first thing that we need to do is look at our next token. So if wat2wasm okay. I forgot my fat arrow again. And what we need to do is we don't know how many params we're actually going to have. So we're going to do a while loop. And we're going to do our while loop as long as our next token is a param. So we'll do next token, kind, tokens, token types, param. And we can say if our next token value is an I32, then cur func dot params push, and this will be wasm primitive I32. All right. Cool. I know we have all of the other kinds of wasm primitives, but because our test file doesn't have an I64, F32, F64, I'll probably leave those as implementation details after the video's done. Let's just go ahead and get this working. So then here, let's move forward to the next one. So if wat2wasm, if we have another token, next, then our next token will be the potential token. Okay. And this is immutable, I'm thinking. Yep. Beautiful. Yeah, let's continue. And let's take a look. So we don't have our params here. I'm going to do another print. So let's see, that was, let's do that after a while. Interesting, because everything was fine before I did this, I believe. Somehow. Let's try this again. Oh, let's do this down here. And I think it's because I broke right there. So instead, let's break after. Oh, interesting. So I think because of this, because we haven't defined what to do when we encounter results or items in our function body, we're actually just adding we're still iterating through over and over again, but we're just continually adding all of the I32s into our params, if I'm interpreting what we're seeing correctly. But at least we're adding all of these. Let's get rid of that break and make it a continue again and see what happens if we keep going. After our, so yeah, we basically keep doing that the entire time that we have a param here. And then once we are done with that, I think that we need to skip ahead again in order to skip past our closing param. So that should just look exactly like this, I think. Only instead of our next token, because next token is only within the scope of our param declaration, we want it to be our regular token. Okay. Next, let's talk about what we do for a result. This should be more straightforward. You can have actually multiple return values in a WebAssembly in a function in a WebAssembly text file, but our functions are simple. We're only going to worry about a single result for now. So I think we should be able to just do cur func result should be, and we know that it's going to be a wasm. For now, let's just do this. And after that, yeah, we know that it's an I32. We could check what it is, but for now, let's just say that it's an I32, and we'll have to do that. And again, to get past our I32 and past our closing paren. And yeah, and then let's do our normal thing that we do. And something about that didn't work the way that I wanted to. Let's try again. Okay. And now let's do the challenging part, which is we can throw that in our wildcard. So this is when we're in function body. So I don't like it when it looks like this. I'm gonna go like that for now. So here, we know that we are at the end of our function body by when we reach a closing paren. So we are going to have a while we don't match. And this is our token kind with a rpar. We will let our instruction be a reference to our token value. We will add the instruction to our current function. Instruction. And then we will check what our next thing is. Okay. And we'll basically continue to do that until we see a right paren. And then once we're done with that, we'll skip past our opening paren and go to our next function. So that'll be tokens next. We know that we are not in a function definition anymore. And let's see. So then this is our ast.push, our current function. And let's see, I think we called it a module. There we go. And let's break out of our while loop too. Okay, let's give it a go. All right, and we actually, I think we just constructed our abstract syntax tree. We have our final print statement over here in our main. So we basically have our abstract syntax tree is a module. Our module is an array of functions. Our first one is exported as add2, has two i32 params. Our body is the following instructions. We have a local get. We get our 0th param. We do a local get with 1. We add the two items at the top of the stack, and our result is an i32. And then our next function is add 4. That is 1, 2, 3, 4. And local get 0, local get 1, local get 2, local get 3, i32. And then 3 i32 adds. Yeah, we have successfully constructed our abstract syntax tree. So the only thing that is left is, at the end of, in the beginning of our next video, we'll traverse our abstract syntax tree and we'll emit the bytecode, the codes that are defined by the WebAssembly spec into an executable WASM file. Thanks for your time. I'll see you next time.